Over the past few weeks, we've been talking about t-tests. So we have two groups and we want to see if they are different. Depending on the groups, we'll use a different kind of t-test, right? But no matter which t we're employing, we have this generic formula: t equals the difference between groups over the difference within groups. So here we can see conceptually we have the distribution of the red group, the distribution of the blue group. We're looking at the difference between their means in the numerator. In the denominator, we're looking at the differences within groups. Remember, every person will react differently, so even within our groups we'll have some differences that we need to control for. This week we're looking at ANOVA, analysis of variance. Now, the good news is that these are exactly the same thing. The difference is, so with the t-test, remember we were comparing two groups. So I can write this down real quick. Let me change the color here. So t-tests, got a weird little drippy pen selected. So a t-test can deal with only two groups. So whether we're talking about independent samples, one sample, paired sample, we're still looking at two groups. It's limited to that. With ANOVA, so that's what we're talking about this week, analysis of variance, it can do two or more groups. So we could still run two in an ANOVA, and in fact we would get the same exact result we would get in a t-test. But ANOVA allows us, it gives us more power. We can look at more groups without influencing, without increasing our family-wise errors. So you can read in your textbook about all of those things, and I hope that you do. But let's focus conceptually on what an ANOVA is. So here I told you in t-test land, we've got t equals the difference between over the difference within. This is exactly what an F statistic is. So ANOVA deals with an F statistic. Conceptually, exact same thing. We're looking at the difference between groups over the difference within groups. So the relationship between t and f, if you square t, you will actually get f. So f is a squared t distribution essentially. The difference conceptually is that we just add another group, right? So say that instead of two groups here, we have the red group, we have the blue group, and we also have our pink group now. So that changes our difference between calculation a little bit, right? So before we had the difference between the red group and the blue group. Now we have to look at the difference between the red group and the pink group, also the pink group and the blue group, and of course we need that within groups variance for there. Conceptually though, these are exactly the same thing. So t-tests deal with differences between two groups, and ANOVA allows us to test two or more groups. So let's work through an example here. So I've tried to replicate what we did with the paired t-test that everyone enjoyed so much. Hopefully the errors are out of this Excel, but again, if you're pretty sure that you get the correct answer, send me a quick email and I'll check it. Remember, this is a lot of heavy programming for me, so if you think there's an error in my work, let me know. I'm certainly not above making errors. Anyway, back to our example here. So this is from your textbook. It's table 12.4 on page 366. So here what they've done, we have three levels of one variable essentially. So we have 10 people in a low stress group, 10 people in a moderate stress group, and another 10 people in a high stress group. And our question is, do these stress groups influence the amount of time people say they will spend with their current employer? So if you're in a low stress job, will you stay in your job longer? Will you stay shorter? Same thing, moderate, how does that influence how long you'll stay with that company? So again, we have three groups here, and so we need to calculate an analysis of variance, ANOVA. So here I have made a similar worksheet to last time. So if we look here, Here we have our low group scores. Here I've just squared them because we need that for some calculation. Our moderate group scores, and again I've squared them. High group scores, high stress group, and then of course I squared them. Looking down here, I've taken the sum of all of these. I've counted how many people we have in each group. There are 10 people. And then I've taken the mean of each of these 3 groups. I've calculated the sum of our x's. I've gotten our total n, the sum of these squared x values here as well, because we'll need those in our calculations. So all of this is done for you. You might have to refer back to it occasionally, but I think that I have gotten us started over here. So same kind of deal, looking at this section over here. This is where we need to start entering some of these things in. So here I've told you your total n is 30, so you can see that here in H15 total n is 30, and I told you earlier there are 10 in each group, right? The sum of our x scores 97.1, so I just added up these 10 people. The sum was 34, added up these 2 people, 33, added up these people, 29, and then I summed those folks right there to get the sum of all of our scores, which is 97.1. Now, we need to start calculating some things here, so we need to find our k, and then some more complicated math here. Now this is all laid out for you in the textbook. Of course they walk through these calculations and I'm just doing them again here. All of these formulae are listed on page 370 to 371 of the Privateera book. We'll go through it here as well. So k is the number of levels of your variable. So again here we have one variable, which is our stress. We have 3 groups of stress. We have a low group, a moderate group, and a high group. So this calculation is pretty easy. I'm just going to put a 3 right there. Same as last time, when you enter the correct number, it's going to turn green, assuming I've done my job here. So here we can start with stage 2. So your textbook divides all of these calculations into multiple steps. So here we can start with stage 2, the sum of the total score squared over n, and then calculation 2, calculation 3, and then we can start looking at sum of squares between groups, sum of squares total, sum of squares error, so on and so forth. So let's do that. So our textbook gives us 3 different formula that we have to start out with. So let's make this. So our first formula is going to be the sum of the x scores. We're going to square that and take that over n. Now, the sum of the total x scores, remember I gave that to you already, so the sum of the total x scores is 97.1. I've given that to you right here. I've also copied that for you right there because it's the first number that you need. So that is going to be 97.1. We're going to have to square that over our total n. So remember we had 10 in each group, so that's going to be 30. That works out to be, so if I just take 97.1 and square it, because we want to start with parentheses, right? 9428.41 over our n. So then the result of this first calculation is going to be 314.28. Go back to our formula here and let's check our work. 314.28. Okay, so that's correct. Now we can do calculation number 2, the sum of x squared over n. So let's be really clear about this. Let me just change the colors here. So 2, I'll make it a little bit darker green, is going to be the sum of our x squareds over n. So that's going to be all of our sums, so 34.3, and then we'll square that over the number of people in that group. Then we have to do it for our other group. So let me show you where I got this 34.3. Here we have our first group, our low group, right? Come down here, I have summed our scores, 34.3. That's all that I put there. So it was the sum of our x in this low group, 34.3. We square that. Our next number is going to be the sum of our moderate group. So that's 33. So I can go back to my work here. So it'll be 33 over squared over n. There were 10 in that group as well, and then that last group was 29.8 squared over 10 in that group as well. If we square 34.3, we're going to get 1176.49. 33 times 33 is 1089. 29.8 times 29.8, 888.04. Now we need to divide by 10 here, and so I'm just going to do a little cheat here. I'm just going to move this 1 to the left. If you move your decimal place over by 1, that's one way to divide by 10. You could certainly just, divide it out with your calculator if that's where you're comfortable. I don't mind that at all. But that gives us 117.649 plus 108.9 plus 88.804. So the results of our second calculation should be 315.35. So 2 should be 315.35. Let's go back and check that real quick. 315.35. Alright, we get the green light. We can go on to our third formula here. And so here we're just restating the sum of x squared. So that number I've done for you right here. So the sum of our total x scores squared. So remember, we took our x, we squared it. We summed those squares. We have our x for the moderate group, and by x I just mean raw score, sorry. Square those, add those up, and then do the same here. So to get ex sub t squared, we're going to take 119 plus 109 plus 90. I've done that for you right here, 319.47. So I'm just going to enter that in, 319.47. So we have that correct. Now we can get into the more interesting kind of F statistic calculation. So there are a couple of different steps to get there. Starting with sum of squares between groups. So this is going to be the between groups variance that we're looking at. So here, let's see, I'm already running out of room, unfortunately. But we know that our, let me change colors again, sum of squares between groups, we can take our results from calculation 2, subtract our results from calculation 1, and that will give us sum of squares between groups. So our result from 2, 31535 minus, looks like 3.1428. So if you work that out, you do that subtraction there, you should get 1.073 for our sum of squares between groups. This is the same kind of deal, the sum of squares that we've been dealing with all semester. We just have multiple groups here, so we have to do it a little bit differently. So sum of squares between groups, 1.073. I'm going to enter this. I set up this worksheet in particular for 2 decimals, so I'm going to do 1.07. Hit enter. That is correct, so we can calculate our sum of squares total. And again, if you look in your textbook, I think I said page 370, they give you all of these formula, and I'll give them in the worksheet as well. But sum of squares total, we take the results from our third calculation, which was just restating that number, and then subtract from our first calculation, which we should have 319.47 minus 314.28. So our total sum of squares are 5.19. We can enter those to check. We're still on the right path. Our next step will be sum of squares error. Now our sum of squares error are going to be our total So it's going to be sum of squares total minus sum of squares between groups. So that will be what we just did, 5.19 minus 1.073, and we get 4.117. So our sum of squares error, 4.117. Round that, 4.12. And we're good to go. Now we need degrees of freedom between degrees of freedom error. Now degrees of freedom, remember, degrees of freedom between degrees of freedom error going to be slightly different. So degrees of freedom between is going to be, should be K. I've set it in here, so K minus 1, and then we've got N minus K. K minus 1, N, actually, N minus K. So the number of levels of our variables, so that's 3 minus 1. So our degrees of freedom between is 2. The number of participants, the total, that's 30, minus our levels, which is 3. So our degrees of freedom error should be 27. So we have 2 and 27 degrees of freedom. You can enter that here, 2 and 27. Okay, so that's an error. That should be correct because K is 3 minus 1 is 2. I'll fix this I'll do that later, and in your worksheet that should work out because this answer is in fact 2. The next thing we need to do, using 2 and 27 degrees of freedom, we need to find the F critical. So please do this on your own real quick. Maybe I can insert a question in here to make you write out your F critical before you can move forward. There's another appendix in the back of your book, so that is 3.35 using 2 and 27 degrees of freedom. Now, let's pause for a moment and fill in some of this information over here. So we have an ANOVA table. This is what SPSS will give us. This is what you would report if I had you do a full APA report on this kind of thing. Sum of squares between groups, we did that over here. Right here, sum of squares between groups, we can do 1.07 turns green. Within groups, sum of squares error, again, we just did that a second ago, 4.12, 4.12, and then the total sum of squares, SS total, 5.19. So far so good. We need degrees of freedom between groups, so that's going to be 2 degrees of freedom error. It was going to be 27. Our total, of course, 27 plus 2 is not 30. It's actually 29. Now, we have to find our mean square between groups, mean square error, and then we can find our F statistic. So mean square between groups is going to be sum of squares between groups divided by degrees of freedom between groups. Pretty straightforward there, but let's go ahead and work it out just to make it painfully obvious. So we want mean square between groups, so it's going to be sum of squares between groups over degrees of freedom between groups. So we know that our sum of square between groups was we rounded to 1.07. I'm going to go ahead and tack that 3 on just because of, I know if we don't, it will end up in a rounding error. Degrees of freedom between groups was 2, so we know our mean square between groups is 0.5365. So we can go in here. Mean square between groups, 0.536. Maybe I did 0.5365. Okay, so you already got a rounding error, 535. Should be 536. So I'll fix that before I give you guys this worksheet. But our mean square between groups, 0.5365. Within groups, again, sum of squares error over degrees of freedom error. Mean squared error equals sum of squares error over degrees of freedom error, which comes out to be 4.117 divided by 27. So again, we rounded this to 4.12, trying to avoid some rounding errors. And that comes out to 0.15248, so we can round that to 0.152. And that is correct. Now, our last, well, almost last step is to calculate our F statistic. So F obtained is going to be our mean square between groups over our mean squared error. So you can still see these numbers right here, 0.5365 over 0.15248. And again, I'm just carrying it out to avoid some rounding errors. So our F obtained should be 3.52. 3.52, and it is. So we have F obtained right here, 3.52. Again, that's another rounding issue that I'll fix before giving to you, so it should turn green. Now we can draw our distribution, right? So we know we have 0 here, we have 1, we have 2, there'll be a 3 out here somewhere. So our F critical, remember, was 3.3 something, so maybe right here. This is the rejection region. Our F obtained was 3.52, so that's going to be right here. So our decision would be to reject the null hypothesis. Now, with a t-test, when you come to this decision, you only have two groups. You had group A and you had group B. So you can say, okay, they are different, and then you can use means to say A was higher than B. Here you have A, B, and C. All this has told us so far is that there's a difference somewhere in between these groups. We need to do all of these pairwise comparisons. So A compared against B, A against C, B against C, to see pairwise which ones are different. So to do that, we would do post hoc tests. I'm not going to hand calculate those. I'll show you how to get those in SPSS, and I'll pull that up right now. So here's a post hoc test. These tables can get kind of difficult to read, but here, so time at job, we have Tukey's test. Your textbook talks about that. We have least significant differences, or LSD, and here what you're seeing is every pairwise comparison. So the low stress group versus the moderate stress group. Go over here, our sig, our p-value is 0.740. These groups are not different. Compare low versus high, on the other hand. Sig is 0.040. There is a difference between the low stress group and the high stress group. Now we need to compare the moderate group to these two. Moderate versus low, 0.74. That's greater than 0.05. These groups are not different. Comparing moderate against high, we go over to our sig value here, 0.178. That is higher than 0.05. This is not statistically significant, so the medium group did not differ from the low or the high group. So we know overall, looking at this as a model, there is a difference. When you want to know specifically what is different, a post hoc test will tell you, according to Tukey's HSD, the low group is different than the high group because it was statistically significant at 0.04. And then we could go back and say, okay, the low group had a mean of this, the high group had a mean of this. Actually, I have this information. The low group mean was 3.4, high was 2.98. So then we conclude the low stress group intended to stay at their current job longer than the high stress group. So that is that's a post hoc test. Again, there are multiple post hocs that you can do, but it's just an extra step with an ANOVA. So we found our F critical, compared it to our F obtained, and we know that our decision is to reject the null. We know there's a difference here somewhere. We looked at some SPSS output. We know the low group intends to stay at their job longer than the high group. The one thing I have not told you is how different these are. So remember, we need our effect size to do that. So effect size in ANOVA, remember in a t-test, it was Cohen's d. In ANOVA, we're going to look at something called eta squared. So it's going to be pronounced ETA squared. So eta, Greek symbol eta. So to find this eta squared, we take our sum of squares between groups over the sum of squares total. So again, just going off of our worksheet, we have 1.073 over 5.19. Our eta squared is 0.2067. We'll round that to 0.21 in a second. Eta squared is a little bit different because we can talk about this in a percentage. So we can say 21% of, so I've just multiplied, so 0.21 times 100 to get our percentage right, 21%. 21% of the variability in length of time at job is attributable to differences in stress. So I said that in a very specific way, be careful. 21% of the variance in the dependent variable, in this case, that is time at job, is attributable to our independent, which in this case is stress level. So you have 100% of something, right? Here we're saying 21% of the variance in that dependent variable, time at job, is attributable to our independent variable, the stress level. So that's a pretty decent effect size there. I'm sure your textbook has the conventions. 21% I would be very happy with. But let's go back and check our work real quick. Our effect size eta 0.21, and that is correct. So this is how to calculate an ANOVA. It is, again, there are very many steps. I can be confusing, so try to work through. I hope you worked through this worksheet with me. And I encourage you to use that for your homework again this week. So to summarize, with ANOVA, analysis of variance, we can have two or more groups, right? So we're looking at the differences between two or more groups. T-tests were only two. ANOVA can handle two or more. We're going to calculate our F statistic to find our P, and that will tell us if there is a difference. Remember, difference, yes, no, and again it would be reject, retain, so same kind of verbiage here. And that is all based on our p-value, which we find using the F, just like we did with the T. We also have to answer, where is the difference? Right? We have more than two groups. Where is that different? Post hocs will tell us that. We have LSD, we have Tukey. There are many, many post hoc tests. Please read in your textbook about a couple of them. And then we have to know, how large is the effect? How large is the effect? Of course, trying to do a question mark there, effect size tells us that in this case we're looking at eta squared, ETA squared, or you can use the symbol for eta in the Greek symbols in words. So ANOVA, two or more groups, you're calculating the p-value or the F statistic to get to the p-value, if there is a difference, so you say this tells you overall where is that difference. Here you want to know pairwise where is that different. You do that with post hoc tests. And then of course you want to know how large is that effect. Eta squared is our ANOVA effect size. Next up, I will show you how to calculate an ANOVA in SPSS. There are two ways to do it. I'm just going to show you one way. I don't want to overcomplicate things. So next up, we'll check our work in SPSS.